everybody. Um, Hello from Romania, from your favorite artist electronist Q12, the great. Alright, what I have here, I commanded a purchase, chip, an IC, and today it arrived. And I said, I will use it in some projects in the future, in the near future or whatever future. But I will definitely use it sometime from now. It's a very interesting chip. I really like it. It's doing a lot of stuff. I mean, very specific chip, very specific. But I really like it because I was trying to display in my last project what I wanted to display. I actually created a converter, a binary to decimal converter, and I was displaying only one LED per clock, pretty much. But this guy, when it's clocking, it's one of its pins. I mean, when this chip is clocked, it's displaying a bunch of LEDs or outputs, is powering its outputs to create a number, pretty much what it does. Here is its PDF. Read it if you want. 4033 it's called. Here in this descriptions, here in this description is everything you need to know. It's very to the point. Yeah, I really like it, and I put my eyes on it, and today it arrived. So I said to prepare myself to make a circuit diagram that is functional and that is actually doing something. I paid for 10 pieces, 104033. I paid $3.3. I paid for 10 of them. It's not cheap. It's not expensive. It's shit. I remember I had my microphone set on boost. Yeah, now it should be okay. So I paid $3.3 for it. And as I said, it's not cheap, it's not expensive. Yeah, because I tend to buy quite a few of chips in the last few years. Yeah, okay. So let me actually present to you. I was searching. The first thing that I did, I searched on internet for diagrams, how to connect it, and I find a couple of circuits, all bad. But there were some hints of good connections there, and I make it work on my side. It's perfectly fine what I have here. One problematic thing was this automatic counter that is using a 555, especially here in the simulator, in the Proteus simulator. But I figured it out in the end. I had a problem, but now it's resolved. So now when I'm pressing play, it will play very nicely, actually. This non-variable frequency counter. If I'm including here a potentiometer in this voltage divider that is created from two resistors at the moment, these two guys, 110 kilo. If I'm putting there a potentiometer, in reality, it will give me absolutely no problem. But here in the simulator is a little bit problematic. So I will keep it as a non-variable frequency generator. It was originally a variable, but I'm getting some very nasty errors because of that potentiometer. And I've always had this problem with the potentiometer hooked up to 555. Some timing problem that is having is counting very quickly. It doesn't know something, whatever. So now let me explain what I did here. I searched actually a lot of circuits on the internet, and the majority didn't work. Few worked, but with very random connections of these pins. They didn't know what they were. Probably the guys that they put the circuits that they made, it worked. For someone they did work, but they didn't really understood it. Probably I searched by images. I didn't search by website to actually read what they wrote there. So now this is my experience. This is what I did alone. I figured it out alone, and as you can see, this is the entire 555 circuit that you are seeing here. This part here. It's only, let me actually point it very clearly, this part here, up until this switch that you can see here. Do you see the switch here? So that switch, let me get out from it. So this switch is between the counter and the manual on-off that I'm, impulse that I'm giving. It's like touching a wire, you know. This is what is doing this, what is called logic toggle is called here in the simulator, which is very good, extremely good. It's exactly as you are taking a wire and put it on the negative and then back to positive, like switching from positive to negative like that on the clock pin. This is what I'm switching here from this binary switch that I have in two modes, and that is going to this clock wire here on this chip. Only the inhibit, this number 2 pin, it's pin number 2. Only the inhibit is absolutely necessary to go to ground, and that's it. The chip will work. This pin RB, I don't know what is from. I did look here, but I didn't really understood it completely. It says ripple bulk in, and this is another ripple bulk out. I really bulk, it means blank. I really didn't understood it. And ripple, nah. But the idea of it is that this RB is, if it's put to positive high to level to logic high, pretty much. If it's set to logic high, it will display a 0. If it's not on logic high, it will not display a 0. Let me actually demonstrate it. If I delete it and play it, right now is on manual. Let me switch it very quickly, 6, 7, 8, and switch it back to manual here. And in manual mode, this is 9, And when I press 0, you see, because this line RBI is not connected to the positive, it will not display anything. And I had quite a good time until I figured it out that was this specific pin. I had to actually read the, the datasheet, and somehow I managed to understood that is this motherfucker pin 3 that is displaying or not displaying that 0. That's it, only for the 0. And now if we count forward, it will start from 1 and so on until 9. But if let me window, and if we are playing right now, let's count, let it count by itself a little bit. 8, 9, and now it is displaying a 0 because this RBI pin on pin 3 is connected to high voltage. And then if we click, it will start again from 1 and everything. Now, another problem, and a very big problem actually, depends what display, I don't know how they are called actually. Yeah, it's display, seven segment display, they are called, these guys here. It matters what the common pin is for them. If it's a common cathode, or CC, as you can see here, common cathode, it means that this pin here is connected through one resistor, 1 kilo in this case, to the negative rail, pretty much. That's what it means, common cathode to minus is connected. But this is working absolutely correctly and fine. But here, if it's common anode, while this pin is connected to plus 5 volts, it will not work at all with this chip. Or at least I didn't figure out if it is a switch of some kind that will actually make it work. It will make some random, I don't know. If you have such a display that I have to check my displays. I have a couple of them, I think 10 of them or 20 of them, and I really don't know if they are anode, common anode or common cathode. And if they are common anode, I'm screwed. I'm very screwed because I will have to insert a most probably for each line I will have to insert a NOT gate to NOT the output and to actually display it correctly like here, and it's a pain in the butthole. This is a very big problem if it's another type of display. Here in the Proteus simulator, this common cathode that I used is called 7seg MPX1 -CC. We can search it here and find it. So 7seg, you see, and you get a list of them, and these guys are not good. These guys with 4 pins, BCD, I believe they are controlled by binary. In binary, they are controlled. BCD it means, or they have some converter inside them, and they are commanded by binary. These guys, I actually put this guy here, the original, the first time I put it, and it is not working. I don't know what is its problem, but it's not working. Absolutely not good. Only where are you? MPX, this MPX QA. Only this common cathode, this guy, only this guy worked, and the rest are some weird shit that we don't need. But if you are using Proteus, be aware there are multiple displays, numerical displays like this, and you have to choose the right one. That's as I'm having it selected already, this with CC at the end. It means common cathode. Now here in this section, I have a test. I was testing the first one that didn't work, like I showed you with the pins on lateral here, and I understood that. So it didn't work with that component. I'm not sure if it will work for you. Maybe I have a problem by myself with that module, with that display, numeric display. But if you don't have a problem with it, use it. I for sure had a problem with it, and I couldn't use it, especially when I hook it up to this chip that I have here. And so that's the testing that I have here. This pin here for this display is the last pin here, and it's having that dot. But this chip is not actually making that dot available. It's not really a big thing, but it was good if it was having that dot option as well. Now I made the next step was to make a counter to 100, pretty much to 99, from 00 to 99. So this is what I just said earlier in the beginning. RBI connected to plus to display a 0, or left in air displays a blank, doesn't display anything. This RBI pin on pin 3. As you can see, let me actually pause it. No, let it work, because you see 89, 90. Okay, now I pause it from the switch here, and I switch to manual. 96, and you will see here on the right side it will display a 0 because this RBI here is connected to positive, and it's going through 15, but it's not connected to 15. I will have to move it. So this will display a 0 here, but this will not display a 0. It will remain blank because it is by design. Because I understood this motherfucker pin RBI not connecting it to positive rail will keep it will keep it in a good sense, with, in a normal way of displaying, pretty much. If I was putting this pin RBI pin 3 to positive there, it was displaying a 0 all the time when it wasn't activated, when it was in the beginning. You will see in a second. So 97, 98, 99, and now it should be 0, 0, but because this guy is not connected, its pin 3 RBI is not connected to positive, is displaying a blank, and this is displaying a 0 because its pin is connected to positive. Pretty much this is the difference, and it's pretty interesting one because yeah, it's very versatile. 1, 2, 3. And you will see when it's reaching 9, it will switch to this other one. This one will display a 1, and this will display a 0, as it should be. 7, 8, 9, and now 10. And we can see actually a 1 and a 0, which is very important. And by this, I managed to create a viable circuit, functional circuit, and I'm very, very pleased with it. Actually, I like it. I like it very much. This chip is awesome. It's a very nice chip. And yeah, to link together these two chips and actually to count further from over the 10 up, you have. Let me close the simulation. I'm actually putting the clock on this pin here that is commanding this first display. This is the clock here, directly on it. And this chip, when it's getting to the 9 and then when it's resetting to 0, this CO, I don't know what it means, CO, carry out. This carry out will toggle, will create an impulse of one clock to the second chip here. That will count up one single number, pretty much. And you can add probably 3 or 4 and count to extra numbers, extra values. And it's pretty, very, very interesting. I really like it, and I will definitely use it. But I wanted to present this circuit diagram that I have here because a lot of people doesn't. Let me modify this very quickly here. It was over that pin, motherfucker. And yeah, a lot of people didn't present the correct diagram on the internet, and I really didn't like the results that I got from the internet. But they were good enough. I mean, I did get an idea of, even if they were not that good. I mean, probably for them it worked, but for me, yeah, well, I like the good stuff. I like to get the good results, not the if it works or not results, the in between. I like the good stuff, and this is the good stuff what I have here. And yeah, if you find it interesting, it is. I believe it's very, very interesting. Chip is doing some very specific task, and I really like it. I put my eyes on it, and yeah, I fell in love with it. It's doing some very, very interesting stuff. Sorry, thank you very much for watching, and I hope you like it. And also leave a like, and see you next time. All right? I hope you learned something with me today. All right. Hello from Romania. Goodbye from Romania, from your favorite artist electronist here, Mr. Q12. Bye bye.